Good morning to all. In this series of systems, in the first unit of signal systems, already we discussed three systems: static and dynamic, casual and non-casual, and time variant and time invariant systems. In this session, we are going to discuss the fourth kind of system, that is linear systems and non-linear systems. Let us start. Now, the fourth one is linear systems and non-linear systems. Linear systems and non-linear systems. Linear and non-linear system. For example, just look at in this kind of systems, one important word is called linearity. Linear. For example, so now we have to make it the classification like the systems. It can be linear and it can be non-linear. Linear and non-linear. For example, look at, you take any equation, y equal to 3x plus 4, for example. This is a linear equation because of its degree equal to 1. For example, y equal to 2x square plus 2x minus 4. This is non-linear. Non-linear means what? Its degree equal to 2. This is non-linear. So special category is called quadratic equation. This is not required. So this is linear, this is not linear. In the same way, the concept now just we are going to differentiate between linear and non-linear systems as well. Now just look at whether a system is linear or non-linear. It has to satisfy firstly two conditions. A system is linear and non-linear. We have to verify two conditions. What are these two conditions? These conditions are, first one, superposition condition. First one is called superposition condition. Second one is called homogeneity condition. Second one is called homogeneity condition. The first one is called superposition condition. Second one is called homogeneity condition. For example, just look at this system, this superposition and homogeneity position, it is just like a kind of operations of addition or subtraction, multiplication like that. For example, adding two numbers, definitely we need two numbers. To subtraction two numbers, we need two numbers. To multiplication or division, what it may be, we need two numbers. Look at, for example, what is 4 plus 6? What is 8 minus 3? What is 8 by 2? Like this. We need two number of integers. In the same way, in linear systems and non-linear systems, we need two signal models. We need two signal models. You have to remember this point. We need two signal points, signal models. For example, the given signal equal to x of t. The given signal model is x of t. Now, we have to generate two signal models from the given signal. What is the given signal? X of t. Now, just we have to derive. Let us assume that x1 of t is one signal and x2 of t can be another signal. In this way, we have to derive two different signals from the given signal x of t. What is the purpose of deriving two signals from a given signal? Because regarding this linear system or non-linear system concept is concerned, First, we have to go for superposition and homogeneity principles. You have to observe these two are having or not in the systems. To verify superposition or homogeneity, for that purpose, we always need two signal models. Two signal models we need. But they don't give two signals. They always give only one signal, x of t. From this signal, we have to define x1 of t and we have to define another signal, x2 of t. These two things students have to remember. Very, very important concept. Especially in case of linear systems and non-linear systems, we have to very much particular about defining two signal models from the given one signal model. Again, one another point is that whether it is a linear system or non-linear system, just these two principles you have to verify. One is superposition, another one is called homogeneity. Now just look at. For example, a signal x of t is given. A signal x of t is given. Now, assume x1 of t is one signal and x2 of t is another signal. From this, x1 is one signal, x2 of t is another signal. Let us consider two non-zero constants. One can be a1 and a2, non-zero. They cannot be zero, any number other than 0. Because two different signals we are assuming. So for each signal, one constant, you can make it. So for these two signals, we are assuming two different constants. These two constants are non-zero values. Now come back this one. Now this is the given signal. What is this signal? This signal is given signal. These two are what? These two are assumed signals. These two are assumed signals. Now just look at what are these a1, a2? A1, a2 are what? Constants. Now come back. Now just look at x1 of t is one signal, x2 of t is another signal. Multiply the first signal with a1, multiply the second signal with a2 and combine, add. Add means what? a1 x of t plus a2 x2 of t, combined signal. Now this is called the principle of superposition. What is this principle? This principle is called principle of superposition. Principle of superposition. Now one more point. Students may have one confusion. Adding two signals can become a one signal or two signals. Now just look at. 4 is a number. 5 is a number. Here a constant 2, a constant 3. Multiply constant with the number 8. Multiply the constant with the number 15. Again add these two. That is equal to 23. Is 23 is a single number or double numbers? Single number always. In the same way, whether a signal x of t is given, we have to define two different signals, x1 of t, x2 of t. For each one signal, we have to assume another two constants, a1 and a2. Here, multiply the constant with the first signal a1 x1 t. Second, multiply the second signal x2 of t. Now, it is a new signal. x1 of t is different, a1 x1 of t is different, because just look at here 4 number is different. After multiplying with constant, it has become 8. 8 is different. The first number 5 is different. Multiplying with constant 3, 15. 15 is different, 5 is different. 8 is different, 4 is different. Addition these two, 23 is another difference one. In this way, just look at x of t is given, x1 of t is a different signal, x2 of t is a different signal. Multiply the constant with x1 of t, it is another different signal. Multiplying a2 with the second signal, A2 X2 of t, it is another signal. Combination or sum of these two signals, this is 100% another new signal. This property is called superposition property. This is superposition property in linear systems and non-linear systems. This is very, very important to understand. Now, second property. What the second property? Homogeneity. What is homogeneity? Now, what the first signal? X1 of t. What the second signal? X2 of t. These two signals should be of same degree. These two should be of same degree. The same degree is called homogeneity. Same degree is called homogeneity. For example, the given signal x of t is degree 1, degree 2. Now is also degree 2. This is also degree 2. For example, this is of degree 3, this is of degree 3, this is of degree 3. You can't change the degree. Now just look at whether it is 3, 3, 3. It is 2, 2, 2. It is 1, 1, 1. That is called homogeneity, having the same degree. All the signals are having the same degree. In the same way, for example, this is 3, this is 3, this is degree 3, this is degree 3. This will be degree 3, this will be degree 3. The entire signal will also be degree 3. All are 3, 3, 3, 3, 3, or 2, 2, 2, 2, 2, or 1, 1, 1, 1, 1. That is called homogeneity principle among the signals. Among the signals. These 2 points students have to understand very clearly. Now just look at So now a given signal, for example, look at x of t is equal to x square. This is for example understanding purpose. Here still I didn't start any problems. In the next session I am going to start. In this session you have to understand each and everything, the grassroots level of this concept, because you can expect 100% one problem on this one, whether system is the linear or non-linearity. So how to make the difference between these two, it is up to you. That's why each and everything grassroots level is being given to you all. Please concentrate on this concept very carefully. Now just look at what the given signal x of t. X of t is equal to x square. Now just look at as a first instance what we should do. You have to create two signals. How do you create? You have to create x of t is equal to x square, and the second one also x of 2 equal to x square. Now let us assume that two constants, these constants will be a1 and a2 non-zero. These are non-zero constants. Now multiply a1 with x1, a1 with x1 of t. So this will become a1 x1 x2, a1 x1 square. Next, multiply a2 with the second signal, x2 of t. This becomes a2 x2 square. Now a1 x1 of t plus a2 x2 of t, it will become a1 x1 square plus a2 x2 square. Now just look at. This is the way. For example, in the given signal, the degree is equal to 2. Just look at wherever you observe, all are of degree 2. All are of degree 2. Now just look at. All are of degree 2. That is called the principle of homogeneity. The principle of homogeneity. Observe this one. This topic is not new to students. You already studied your topic in paper, intermediate paper, second paper physics, superposition principle and homogeneity principle. Here we are having applications of those principles here. So now again just recollecting important points. The fourth kind of system just we started with is linear systems and non-linear systems, whether it is linearity or non-linearity. Here it is based upon the principles of superposition and homogeneity. Now you already understood what do you mean by superposition. Now already cleared that what do you mean by homogeneity. So before going for the verification of linearity and non-linearity of systems, students have to observe these two important principles in the beginning. Then only we will talk of whether it is linearity or non-linearity. Now there are some working examples on this one. In the next session we are going to define we are going to divide whether the system belongs to linear or non-linear. Thank you.